at the beginning. Now let's look at the content. So today, the content will be more of a advanced advanced like coding concept. So if you are more experienced in Wolfram language, it'll be better because some of the code are more complicated and I wouldn't explain the code very much. And we're going to give a fast preview of a data science pipeline from cleaning the data and analyze the data from a surface point and going deeper into the data. So yeah, that will be today. So what's cooking? Today we'll be looking at how to build a data science pipeline for recipe classification. So we'll give an overview of how a data science workflow looks like, planning a workflow, how we're doing it in the Wolfram language, and if it's reproducible. So what we're doing is first to define the question. So what are we doing here? What are we trying to achieve here? So, and then we have the data. What are we going to do about the data? So the steps are importing the data first, and then checking the data to see if everything is valid, and then later cleaning the data to take out the outliers, take out the noises, just for a very basic cleaning at that point. And after the cleaning, we can dive in a little bit more on the data to explore what kind of cuisines are there, what kind of recipes are there, what ingredients. And after we have a better understanding of the data structure of what the data are actually doing, then we can continue to do the analysis of the data. We'll have some classify going on and then modified method targeting on different aspects of the data and training a classifier. And in the end, we have processed all of the data. We need to deliver our result to either customer or we're doing a presentation. So yeah, the last part, communication, the visualization part is also very, very important. So yeah, let's start. So data science workflows. What are we going to do? I've just gave a very quick introduction there. So the expectation of how to analyze a set of data is that, oh, we have this data and we just build a model and then we just use the model to analyze the data and we have some insights. But in reality, it is more complicated than the expectation. In reality, when we have data, and the first step is to do some data cleaning because, well, I mean, same thing as coding, garbage in, garbage out, right? So when we have the data, we need to verify, first of all of the inputs are valid. There might be data that only contains zeros. That's not gonna contributing to what the result will be. There might be data that are in wrong types, like saying that it should be an integer, but it's a string. So yeah, the first step, data cleaning, is to make sure that later our work is meaningful. So yeah, the data cleaning also includes some of the like ripping up the outliers. We have examples about that because yeah, those outliers are not contributing more to the data actually. So we want to look more into the more concentrated area there. So the next step is data processing, data augmentation. So yeah, this tool, it's also, I would say also included in the data cleaning part, but yeah, just giving you a better understanding of what the data is. And yeah, once we have the understanding of the data, then we can go deeper into the training, testing, validation, and select a model, build a model, and training again. And after the training, we need to test the model, if the model is giving some valid answers, and if training not working as well as we would like, then we go back. We maybe need to do some more about data part, and then we do a retraining and a cross validation, and like later, like more towards the end, we have the result. And after we have the result, and we can do some visualizations about it. So yeah, like all these things in between will lead us finally to the insight. It's what we can present. It's where we have a like final understanding of what the data is telling us. So yeah, the Wolfram workflow, it's just about the same as how I describe it at the beginning. We have the question, we define the question, what do we want? What are we trying to see through this data? If sometimes we don't have answers to that question yet, but just keep it in mind, like the exploration, the looking at the data also contributes to asking my question. So what can I do with all of this data? And data wrangling, explore, analyze, communicate. So in Wolfram language, we have all different functionalities to support like every step of the data pipeline. We have this broad range interfaces and techniques. We have interactive notebooks. So what I'm presenting now, it's in a notebook, and you can see later. So for now, I'm just using it as a presenting like text image mixture, but later I'll show some code and I can evaluate the code right there, and you can see the result instantly. And we also have natural language queries for data and instant visualization, and we'll see later, automated machine learning, which we have a whole framework for you to try out. It could be as simple as one-line code, or it can be very customizable depending on what you need. And you can implement neural networks with ease and efficiency. We have a building function for neural networks, and we also have a neural network repository, which means that you can go check what's existing out there and try to use them in your work, or try to alternate them to fit your workflow. So I have this report generation and cloud deployment. These two will just be like later for the result part, will just be easy for you to share your work. So how can this workflow help? So yeah, it will just be agile data science, interactive process of tweaking and improving. You just do it like right here. You don't have to go somewhere and wait for the result. And you can use small examples to help you understand things, to start with things, and have this rapid prototyping. And what we wanted to do in the end is this reproducible research. By publishing your work, others can run similar analysis to do the similar thing. So today you can get this copy of my presenting notebook today, and you can run all of my code just fine. You can also follow the steps there and try to make your own projects, something like that. So yeah, or you can also explore more, because today we only have 1.5 hours. So there might be some areas that we wanted to try, but we haven't had the time to try. But once you get the data, you can just continue what we're doing here today. All right, so here is the reproducible research checklist. So first of all, it's good planning helps. I would say having a mental map in your mind or writing down will help you understand what the workflow should be. So the first step is plan out a modular pipeline for the analysis. You need to wrangle with the data and cleaning the data, and need to, like, just on a surface level, look at the data to understand what we have and what are the possible things that we could do with it. And later do a data processing, modeling, validation, and visualization. The second point of it's being reproducible is to be more automated wherever possible, using scripts instead of point and click, because when it's more automated, then there are less human errors, like coding wise, that there's one line of code that I forgot to run, and then it will result in like all of the following code not working properly. So yeah, automation will be helpful to reduce that human error there. And number 3, document your code. Personally, I don't like doing this, to be honest, but it is very important to document your code. First of all, it will help yourself understand your own work. Sometimes the code get complicated and you're just losing your thoughts. Maybe after 1 or 2 weeks, when you come back and revisit, it will just take extra time to understand your own code. And second, documenting your code will also help with, like, later other people are looking at your work. For example, code review, for example, just borrowing your project for their own purpose, then they will have a better understanding of your code if it's documented. So yeah, please do that. And the next point is use version control. So this one, it just saves a lot of mental tracking down. Like, you can try for something, and if it works, that's great. If it's not, you can always go back to the older version instead of yourself making the changes like backwards. By using version control, it will just be some typing, and then it's like a time machine. But yeah, there are a lot of good practice, bad practice about version control, but that's not our topic of today. So yeah, use version control is also very important in the whole process. And the next point is record and preserve. We want to keep all of the sources, the raw data, the goals, the references. So when you come back at the beginning of the question, like, what are we going to do? And it's like, if there's anything happens during the process, you don't want to lose your data. So yeah, keep all the sources. And for the process, for the explorations, for the code, definitely just record everything and preserve everything. Then again, if something goes wrong, then you can always go back to look at these. and the output, the clean data, the graphics, the reports. Yeah, like in softwares, it just like no matter how hard everybody's trying to avoid it, we all have that time. It's just, oh, it suddenly crashed, or oh, I forgot to save it. Oh, which version did I actually use things to produce things? We lose things. That's just human nature. That's okay. But yeah, once you have some clean data that you're happy about, please save them so that next time you don't have to go through all of your code. Again, human error there. To go through all of your code, then maybe you have a different version of your data, and that will definitely pollute like what's going on like later. So yeah, record the clean data. And also for the graphics reports, you can do some experiments with them, but for the final result, please keep a copy. So just for saving ourselves sometimes. All right, the next is prepare for the world changing. Things will change. Sources will get removed. Recently, there was one thing that I looked at. It's in the United States, there was some government data. Oh, it was some NASA data, and it just got removed. And I need to go back somewhere to find it again. And this time, instead of a link, I kept a file copy of that. So yeah, that's also something. And the last point is prepare for portability. So I know so cloud is one thing you can put your files on, or if we go old school, you can put it on a USB stick. So yeah, just make some copies if possible. Or the version control is also a good source of the portability support. So yeah, that's the checklist. What we need to know, what do we need to plan in our head for data science pipeline. So now let's look at our example of today. So the first step, asking our question, what's cooking? So here's the background. In 2015, Yamli provided a dataset for a playground competition on Kaggle. Here we can see the data, how the data looks like. So everything has an ID number, and also identifying which cuisine, which country's cuisine it is, and also the ingredient, having turmeric, vegetable, all of this. So yeah, the data will look like a whole data set containing all of this information. The question is, given a list of ingredients, can you classify the cuisine? So basically we have, oh, if something has red lentils and blah, 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 another 10 ingredients, can I guess it is an Indian cuisine or not? Or I'll guess, oh, it's an Italian cuisine. I don't know yet. So now we are going to look into the data. Here is the data wrangling part. So first of all, we need to import the data. We have the data downloaded in the additional files. I think that also got sent out together with this notebook. So first of all, we need to check our directory, and so import will search for files in the current working directory, which is not where my file is. So I want to set the working directory to be the additional files folder. So yeah, because I put my notebook in the same folder as the additional files folder. So everything, this one will just gave me the correct working directory. So the recipe data is in a JSON file, and we would like to check the file before importing all data by using this import function. And after it goes through, then we can actually import the data. All right, let's see what it looks like. So yeah, I'm just getting the first entry of the data, which has the ID number, the cuisine, and the ingredients, just like how it looks like here. So there will be a pack of all of this data. So now let's look more into the data. So first of all, we want to check the data, the dimension of the data. So here it means it in total have about 40,000 items, and each items have three different aspects, like here, the ID, the cuisine, and the ingredients. And in total, we have about 40,000 of them. And we can look at a sample of the data. I just looked at the first one, and here I'm just picking some random samples from it. So yeah, they all look the same. So now we're doing the first step of structuring the data into a more Wolfram language way. So we want to put the data into associations. The association is just a different structure of the data. So this one it's a list. It's a list of a list, and this one is association. So here you can see this bracket here. So with association, it is easier for us to picking up the key, which is this ID, cuisine, and ingredients, and also the values here is this number, and so on and so forth. And now we can take a look at the number of ingredients. So here, what we're doing is we take all of the values of ingredients from each recipe, and we put them into one huge list. So all of the ingredients, there are 428,000 ingredients. And yeah, apparently there are ingredients that appears in different recipes, like let's say olive oil. I would assume like 2,000 recipes have that. So yeah, but that's everything. And now we need to clean up all of that. We want to see what's the unique ingredients. If olive oils appears 2,000 times, I only want to see it one time as one unique ingredient. So we're using the delete duplicates to get that. And all the unique ingredients after the cleaning up end up being like about 7,000. All right. So yeah, that's just one first step of looking at the ingredients. I can also look at like how many cuisines there are, how many unique cuisines there are. But yeah, that's just for one example. So the next thing we want to check is the data types are appropriate and constant. So yeah, here what we're doing is we have the data type. So for all of the IDs they're all integers. And for all of the cuisines, they're all strings. And for ingredients, they're list. So coming back to one of our examples here. So this one, So all of IDs here is a integer, and cuisines are all strings. So when the data type is consistent, then this will make sure that there won't be surprises like later you're analyzing on it. Just for one example, this 5705, it looks like an integer, but it might be a string. That's why we need to check. Like if later I want to do, well, we probably wouldn't do some addition, wouldn't be do some math using all these IDs, but just for one example, if I want to do this 5,000 plus 3,000, and this one is actually a string, and I'm adding it with an integer, then definitely the system is going to complain. So what we're doing here is to eliminate all those possible issues so that we don't have to worry about it like later. All right, so yeah, now everything got checked here, and we also want to see if there are any unusual string characters. So this is because that again, it's a data set. There might be some like code errors, some importing errors here and there. So we would like to see if those exist and to think about if there's anything that looks particularly wrong, then how are we going to go clean those up? So here we have the numbers, we have a space, we have a underscore, dash, percentage, some letters with accent, and this trademark stuff. So yeah, at this point, it was just getting an idea of what's in there without actually looking into them line by line. All right, now we're looking at the magnitude of the data. So check the numbers of ingredients in each recipe is reasonable and find the frequency with which they occur. So we're just plotting a histogram here. So number of ingredients in the recipe. So yeah, this is a histogram. And we can see there are something that's extremely long here. Like there's one example here. There are some here, but the majority of the data was in from 0 to about 30 in this area. So that will be the data that we're actually interested in. And like after 30, I would say those are outliers that we don't really care. All right, now let's look at the string length of each ingredient and find the reasonable length and the frequency. So the string length of ingredients also looks like they should be under string length of 30, and there are some that is way longer. And here it's like, there are some way longer ones. But yeah, the majority of the data lives, let's just say, under the 40 character length. And that would be something that we are more interested in. All right. The list of unique cuisines seems reasonable because we had Italian cuisine, Mexican, French, Chinese, but those are named after their country name. But there are cuisines that are not named after the country but by the area. For example, this Cajun, Creole. So it is a Cajun country, otherwise known as French Louisiana. It's in America, and there are also this southern U.S. Area. So these two cuisines doesn't map back to where the country is. So we might need to do some extra work on it. So let's see what we have for the different type of cuisines. We have this Greek, Filipino. Yeah, so most of them just goes after their country name, but only these two are not. So we're gonna do something about it. And yeah, after we deal with the area, mapping it back to its um its location, then we also want to look at what we're going to do with the duplicate ingredients. So they might be similar in names, but in the end, we will know they're exactly the same thing. So the unique ingredients have about 7,000. And if we look a little deeper in it, so let's just basically search for anything that contains the word garlic. And we'll see we have this whole list of garlic related things. Garlic and garlic powder. Well, these two I would say they're different things. Garlic paste, garlic cloves. I would say this one is just basically garlic, right? And crushed garlic. So yeah, in principle, they are the same thing. They're very similar, and we need to think about if like how much do we want to keep it, and if we're removing the duplicates, how are we going to do it? All right, now it's more about restructuring the data. So as you have seen, there are some potential outliers and near duplicates that need us to deal with them before we process more. So first of all, we don't need the ID number. As I said, we're not consulting, oh, is this 5333? Can this be a deciding factor of which cuisine it is? No, it couldn't. We're not doing any math about it either. So the first thing we would like to do is to drop all of the ID column. So again, after we drop the ID column, we can see the only thing left was cuisine and ingredients. And now, before we look into this, let's see what is the length of this. All right. Now, we don't know if there are any duplicates in it, but if so, we'll do an extra step of delete duplicates just in case. So yeah, this goes back to the same variable name. So I will try to do this again. Remember the number. Oh, after I did the cleaning, the number shrinked for a little bit, probably less than 100. So that's a good step. And now we can get a random sample of the data to take a look at. They can either be in a dataset or in a tabular form, but yeah, in the end, they're just data. So yeah, we have the cuisine name and then we have all of the ingredients. All right, then we need to further clean the data, like normalizing the data. The first one we would like to do is the thing we mentioned before, that we might want to map these two cuisines to their actual location. So rather than merging the two together, we can use replace to swap southern US with Florida and Cajun with Louisiana. So what we're doing here is to It's a very basic replace rule, just replacing this name with Florida and replacing this name with Louisiana. So if we're looking at something in this recipe data, the cuisine should either be going to Florida or Louisiana. It would be beneficial to convert the nationalities to entities, which are rich with useful metadata. So this one, we can use the country interpreter on the data. So yeah, I would assume that this one will need a second. All right, so we can see all of these are now translate from a string to these little orange boxes, entities we call them. So they contains more information than it looks like here. And again, we notice that Florida and Louisiana, they're not countries. That's why they're producing these failures, which makes sense. We can deal with them later. So yeah, let's fix the interpretation manually with freeform input. So this Florida, it's all right. So you just saw me typing there, and this time it's asking me if it's the administrative division of Florida, the state in United States, and also for this Louisiana, and I can also. So to enable the free form input, um, you just need to type the type this, or I believe there's a manual button for that somewhere. But yeah, I can also do this. Florida, US. All right. So yeah, it is interpreted as Florida, United States. It's the same as this one. So now, we can see the cuisine location now was just got updated to this, the whole list of the cuisine and the related location, country or location they have in the world. So once we have this association as a replacement rule to change all of the cuisines in the data. So basically we're bringing these little orange boxes back into our original, like into here. So this Japanese will be replaced by a orange Japanese little box. In this way, we can query for more data more easily. Like now we have this country entities, we will be easily getting the information of the population of the country and the location of the country for easier visualization of a map. So yeah, the replacement's done. And excluding Florida and Louisiana, the nationality values can be recovered from these entities if necessary. So we can query for the entity value of the cuisines. So yeah, I can do this entity value of Grace. Let's see. Oh, and nationality name. And then it'll give me Greek again. So yeah, that's just one example of what information can we get back from the entities. And there are also a lot of other metadatas for a country. So we have 762 different aspects as I said, we have the name, apparently we have the location, the coordinates, we have what capital city that country has, we have the population, and I believe we have GPT. So yeah, all of those information containing this. So here are just some examples of the properties. Have the independence, date, trade value, something like that. All right. So after a look at the cuisines, now we're looking at the ingredients. What more information can we get? So the ingredients contains a lot of irregular characters. As I said, the with accents and with all of these symbols, and we need to look more into what's going on there. All right, now let's take a look at string, all of strings containing this percentage. So this one makes sense, 1% low-fat milk. So if we want to look more into this, then we can take all of the examples here, but now we're just showing one. And there are some that doesn't make any sense. Like for this one, it's the trademark. For this one, I have no idea. All right, so yeah, there's also some like trademark stuff, but didn't got coded correctly back into this string form, something like that. So, and this one is a brand name. So brand A olive oil and brand B olive oil, they're both olive oils. So this is just unnecessary information. So now what we're doing is to delete the unwanted characters, brand names, and accents for the ingredients. Um, all right, so that's the first step, cleaning those, and we also want to remove excess white space, converting to lowercase and deleting duplicates, all of that, and we do that again. And there are now slightly fewer unique ingredients. So this is before we do the cleanup, and then this is after we do the cleanup. So yeah, I would say at this point, it it might be a good point that you stop and store the data as one of the step already. All right. Now, so for all of the cases above, it's more of a grammar fix. Just see if everything is valid and see if there are wrong characters existing there. But like later, this part cleaning the data is more on the data science part, like by reducing the outliers. So yeah, the first one, we want to remove recipes with an excessive number of ingredients because they're just way too unique to be contributing to the data itself. So here we're removing anything that has more than 30 ingredients. And remember, we have the histogram showing like the majority of the recipes have less than 30 ingredients. Right. And the next step, we want to look at the ingredients list. So again, remembering we're seeing the histogram of the ingredients, and everything there was smaller than the string length should be smaller than 40. And now here we're just being a little harsh to put it on 32. So all of the length of the ingredients should be less than 30. All right, so Now, after the cleaning again, we have the ingredients shortened as to be this one. It was 40,000 something, but now under 40,000. So here, yeah, again, we should store the cleaned data, and I've done that, and you can find it in the additional files folder if needed. So yeah, the number of unique ingredients has dropped further, which I remember is 6,700 something, and now it's 6,300 something. So yeah, now let's think about our garlic issue. Depending on the goal of the project, you might want to remove the near duplicate ingredients. Yes, you might want to keep them. That's all depending on the goal of the project. So in this one, there are different ways to do the cleaning. So we're just showing some examples. You might have different criteria in your thinking that how do I want to do this? So yeah, it's all worth a try. There's no like a completely correct and completely wrong way. Everything we do here to do the cleaning is to later serve our purpose of answering the question. So here we're trying to delete any ingredients that contains another. So garlic cloves contains garlic, so we're removing this. But this might be a little bit overkill. For example, garlic paste, which is also garlic powder, which is also will also get removed. But well, in my opinion, there are different ingredients than garlic. All right, so this got cleaned, and we look at the length again, and this time it got reduced significantly. We had, yeah, this was our number before the near duplicate values, and this was after doing that. And there is another way of doing this. Is a more selective approach might be to delete any that overlaps with another by some number of characters. So this one will need some time to run. So I have done that before. And let me just import that back. So yeah, the idea is basically the same. So now, if they overlap, then I clean those out. So now we only have 800 left comparing to our 1600. So that might be more overkilling. So yeah, neither of these approaches is perfect. The second one, it just is a little bit too much, removing many ingredients that are perfectly valid, non-duplicate. We can say we want to look at anything that's related to tomato. And for the first approach, after our cleanup, this is what has been left. And for the second approach, this is definitely an overkill. Like it basically removed tomatoes already, which is definitely not correct. So yeah, there are a lot of other different ways to think about how you want to do the cleaning. There are options to look at the spelling, stop words, and it might also be helpful to use some of the LLM functions to support this. But yeah, again, with LLM, there's other issues. So yeah, just try some different approaches and to see which one can serve the purpose better. All right, that's our first step of the cleaning. And now we're going to explore the data. So first of all is how many cuisines are there? And we can get the list of unique cuisines and find the length of it, which is 20. How many recipes belongs to each cuisine? This one is also like very simple, just to do a count of all of the cuisines. And particularly in this data set, there are more Italian food and more Mexican food recipes up there. And yeah, you can just see the numbers. And once we have the numbers, we can produce a pie chart, which is also easy, like a easy visualization for you to see. Yeah, in Wolfram language, the visualization part, it's one of its strong side, I would say. A lot of customizations and have different colors, and you can decide how to label all of this. Do we want the numbers here, or maybe we want the numbers under here? So all of that are customizable. That will help a lot with visualization. All right, the next thing we want to look at is where are the cuisines from? All right, this one will give us a world map for where are the cuisines from. And here it's Italy. I apologize for the small hover over. So yeah, the legend is like when it's more towards the red side, then there are more cuisines. And here is Mexico cuisines and Brazil, all of that. So yeah, this is a great visualization to help you understand in which country how many recipes are there. All right. So yeah, how many recipes are there? And we can see that. So since duplicates were removed earlier, the number of recipes should equal the length of the data, which makes sense. So we're just proving that is correct. So what is the average number of ingredients in a recipe? So find the average number of ingredients in each recipe. First of all, we get the length of each recipe, like how many ingredients in each recipe. You can say it's like 10 something ish. And now we can do the basic statistics on them. The mean is 10.6, the median is 10. And can also calculate several standard statistical measures all together and present the result. What are the longest and shortest recipe? We can use this minimal by to get a sample of the shortest recipe, which is just only one ingredient, and the maximum. This one has 30. Yeah, all of this was because we cleaned up everything that is above 30. So the longest you would say is 30 now. But if we use this one to the original data set before we do any cleaning, and this one probably goes to like 40, 50, something like that. All right, how many ingredients are there in each recipe? Again, we can do a histogram, and we have already done that for the first step. And then that was when there are a lot of things after the 30s, and we decided those are outliers, so they're gone now. And now we only have from 0 to 30. And yeah, confident intervals, you can just see what is the 90% confident interval in the histogram. So those pretty standard statistical analysis stuff. All right. Now, let's look at what does a typical recipe look like. So first of all, run a food interpreter on each of the unique ingredients. Um, so this, when I see it's a tomato, it will translate it to, it will interpret it to a food entity, which is the orange, little orange box of the tomato there. So, all right, now let's ask for 3 different examples. We have yogurt, we have cracker, we have arrowroot. So yeah, there are more information contained in that. And for the food entities, they are also having a lot of information like the country entities with this metadata. And we have 600 different properties within one food item. All right, so yeah, here we're again looking back to the recipes and ingredients and removing those duplicates, remove duplicates remove duplicate recipes and remove duplicates ingredients, and all has left was just the recipes, and we'll get a random recipe and group its entities. So this random one we get is egg, herbs, olive oil, and onion. I don't know which one this comes from. But again, once we have this information, we can query for the nutrition information about the food here. So we can see the distribution of calories, protein, fat, and carbs. And we can also query for a nutrition label, which will take a minute. All right. So yeah, it has the daily value and like what's the total fat, all of those information. That will be helpful for the health information. All right. Now let's look at the ingredients. How many unique ingredients are there? We have looked at this a couple of times today. So yeah, after I deleted the duplicates and the length of ingredients, have all of this, and what are the least and most common ingredients? So unique ingredient counts. So the most common are salt and olive oil, order, onion, garlic. You can also see it in the word cloud. So yeah, when it's bigger, it means that there's more appearance on that. So yeah, that's also a good way to visualize what how frequent the ingredients appears. So yeah, that's our like the surface look at the data to have a basic understanding of the data. And now we want to do more analysis on it. So which ingredients are often bind together? So here we can see the count of back ribs and crumbles are often combined together, and back ribs and pepper. So this is just pairing different ingredients and then doing the count in the recipes. And the majority of ingredients pairs appears only in one recipe. but there are some that pairs more. Some ingredients appears together very often, and we're looking at those: pepper and salt, olive oil and salt, which all make sense. And how do the regular recipes compare to the unique ingredient recipes? So yeah, this is just a visualization of how the data is shaped and where is the more interesting area to look at. What do the ingredients feature looks like in feature space? So we use the function feature space plot to cluster ingredients that they're near to each other according to some features. In this case, we're using the string length as how to cluster them together. Let's just give it a second. It's still running. So yeah, at the meantime, let me show you the example page, the documentation page of this feature space plot. So yeah, here you can get all of the syntax and what different aspects that you can fine tuning. And we also have the basic examples of how to use this function. So it will help you better with starting to write in Wolfram language. And now this has been clustered. So our criteria is to use the string length to cluster them. So we can see here, these little blue dots together, they are the clustering. And you can see the label that they're clustered by the string length. We can also use the list polar plot to represent the same information. And this time it was just colored differently. They're all the same. It's just the visualization is different and the approach is different. What do the recipe feature looks like in feature space? So a feature space plot can be recreated manually, reduce each recipe to two dimension with dimension reduce. And now each recipe is two-dimensional, and we can, after it got reduced to two-dimensional, then we can plot it out. As we can see, the dimension reduce is also a feature extraction in some sense. So as we can see here, the similar cuisine is clustered together. And we can also look at each cuisine separately. So yeah, I was just plotting each cuisine on their own plot, and we can see a lot of clustering in this Mexico and Italy and Vietnam, all of this, and South Korea is a little bit spread it out. How many recipes are there per capita? So this one comes back on the country information. So here we're just using the recipe numbers to divide it by the population and something like that. So yeah, which cuisine tends to have the most calorific recipe? So again, this comes back to consult the food data, and most of them are lower in calorie counts, and some of them are getting more to the 400 ones. So here we're getting the total number of calories in each recipe. So this example is in Greek cuisine, what are the calories are, and also we can use this distribution chart to visualize the calorie distribution. So we can see this Brazil one is on the lower side, and here Jamaica one is a little bit towards the right side. So yeah, this is just giving you an understanding of what different aspects we can look at and what kind of visualization we can look at. So now we goes to the automated machine learning part. So with the data more deeply explored, it's time to build a model to answer the project question. Given a list of ingredients, can you classify the cuisine? So here, the classification problem will be solved by our building function, which is called classify. So first of all, we want to set up our data. So training a model will be quicker if the entities, which is the orange, the yellow-orange boxes, which carries with them a lot of metadata. So if they are not in use, then that will be quicker for classify to process. So first of all, we just convert everything back to a basic string. So yeah, that is just one data wrangling back. Now we want to restructure the data into a list of examples, goes to class pairs, ready for classify. So classify takes a lot of different structures of data. But yeah, for this one, we are just cleaning the data to shape it better to work for classify. So now is the very basic machine learning, preparing the data to divide the data into training and testing sets, typically 80-20 splits. So yeah, that's just the preparation. And now we can create and train a model. So the only thing you need to do is to use this classify function and then to put the training data in it. If you don't specify anything, then classify will try to automate many aspects for the training process. So that was like extremely quick. And now we can take a look at the performance of the model. The classifier measurements, it's the function we would like to use to look at the information of the classifier. So here we can see for the automated method choice, it chose Markov, and the accuracy was about 75%, and all of those meta information. And this is a confusion matrix that will show you which recipe that it did a better job and which recipe it got confused. So as we can see here, the Italian ones was pretty decent, and the Mexican was pretty decent too. Because this too is because there are more examples of them in the training data. So if you see the correct answer more, then you're more likely to answer it correctly when got tested. So yeah, so understanding the matrix, the confusion matrix, will help you to modify your method, to modify your data, to retrain, to have a better prediction. So here are the properties that you can query from the classifier measurements, and the accuracy, the confusion matrix plot, which is just that one. You can just correct precision, worst classified example. Yeah, these are the more important information to help you polish the model. So let's just say, my model is very bad at deciding this recipe. Why is it bad? So that's the question that we need to ask ourselves when we're redo the training. All right, so this one, the original one was Filipino, but it got predicted as Louisiana. Why? There might be something hidden in the ingredients that I think that is Louisiana, and this one, Japanese got confused with Indian food because it might be because it has cinnamon and coriander clove, masala, all of this Indian ingredients in it, so it might get confused. So now we get the top confusions. So French got identified as Italian food, Florida got Louisiana, which these two are about the same. Greek, Italian, British, Florida. So I can view them as a graph. So Greek was confused with Italian, Italian with Spanish, Italian with French, all of this. And here are some two separate. They're not linked to the main graph, but they have their own confusions between each other. Again, we can also put it on a world map to see which I don't think this map is a good projection, because in theory that Europe and America was not that far away. And also, like, here is our two Asian countries together. So yeah, you can change the geo projection to have a more of a map that we're usually familiar with. All right, so now let's do some customizing of machine learning. We want to reduce the bias. So the first method is to balance out our data. Remember, some of the cuisines has more recipes and they appear more frequently in the data than others, like Italian have a lot, and towards the end, Brazil doesn't have a lot. So what we're doing here is to create a balanced set of training data. So yeah, I'm writing some documenting my code here so that you can understand, like, in which step what was achieved there. So for each cuisine, getting the same amount as the smallest cuisine count of the data. So we have a new training data. And let's check if every cuisine now have the same number. And yes, then we can go again. And this time, same thing, using classify to test on the training data. And now we have trained it again, so we want to look at the information again. Compare the measurements with those from the original model. So yeah, the original has accuracy 75%, the balanced one is lower. This might be the reason that our balanced one each have even smaller amount of data to look at. So yeah, which makes sense. So yeah, so then this might not be our approach to take. Another solution is to tell the model that distribution of outcomes you're expecting. So we're giving the prior assumptions here, prior assumptions here. So here we gave the class priors as 1 over the length. So it's basically saying that, oh, each recipe should have the same probabilities to appears in the cuisines. So let's do it again with a training with a classifier. And now we have another classifier measurement. And this time it got boosted back to 71%. All right. And another approach is to look at the features. Classify learns by identifying features in the data. Sometimes getting a better model can be as simple as changing the data structure. So add some new examples to the balanced training data by shuffling the order of ingredients in existing recipes. So instead of like tomato, milk, cheese, blah, 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 I just shuffle all of the ingredients to create a new entry for the data. So this will increase our training data, the number of our training data, and now we're retrain it again with that data. And here noticing I'm setting the time goal to 60 seconds. You can also set different goals for your data. You want it to be better performs, but you don't you don't care about the speed of it, or if you're not specifying it, the model will just decide by itself to being more of a balanced way. But here, this example usually takes longer, so I'm limiting the time here. Again, once it's trained, we come back and look at the classifier measurements. All right. So same thing. All right. Another thing is to convert each list of ingredients to single strings, forcing classify to use a different approach when learning from. So for the previous examples, we gave it a list of things. So there might be some noise in it, like the length of the recipe. There are 30 ingredients, or each of the ingredient length. That might be some of the features that got extracted, but we might know that's not correlated. So here we're forcing classify to think about it in a different way. So first of all, we set up the training and testing data by converting the list of strings to one single string. And again, we're training a new model with the same classify training. And again, we can look at the classifier measurements. Yeah, same thing. So yeah, it looks like the accuracy was just about this 71%. And we can also do a feature extraction again. So here for feature extraction, we can use different method here. And here I'm specifying it. There are a lot of other different methods that you can use. So this one, for classify, again, I'm giving the training data, and this time I'm specifying the feature extractor should be the one that I used. So yeah, we can look at this monitor to see what is currently going on with the training, and the learning curve should just goes down. And there are some other aspects. The accurate, it's because it's trying things here and there. It can go up, it can go down. All right, looks like there are some technical issues happening there. But yeah, let me kill it so that it won't affect anything else. But yeah, sometimes with machine learning, it happens because of it's pretty resource consuming. This sometimes happens with like larger data set, and also it's based on your how your hardware is. So yeah, those are the times that we need to think about. Oh, save your work. But yeah, so now it figured out itself. So we can again look at our classifier function. So yeah, this is the confusion matrix. So yeah, this example is also about the different options of classify. We've seen it, different method, and just the method. One we use that it automatically chose was Markov, and we also use the feature extractor. So I'm not gonna show this example. But one thing I wanted to mention is the validation data set. So for validation data set, it will provide a data set in the training process that it cross-validate. So it's basically not answering question with already given correct answer. And this is just the typical data ratio for this type of tasks. Again, I'm training it using a classifier and training data and giving the validation set, and then testing it using our testing data. So yeah, this time the accuracy got a little bit better. All right, so now we have our model ready, and we want to look at the real data. So from the computation, we got given a data set that only has the ID and ingredients. It doesn't tell you what the cuisine is, and that's what we want to decide. So first of all, we need to set up the testing data again by removing all of the IDs. And now we're using our final model to do the classifier. So yeah, here just splitting the data into training and validating sets, and it is a 80-20 ratio. And now we're adding more examples to the training data and creating and training a new model. So this is a combination of all of the different approaches that we tried earlier. So yeah, let's see how long this one will take. I would assume it will take a little bit. All right, great. So now we have our classifier function. We can apply the model to the testing data. So yeah, this one should also take a little bit. All right, so now this is finished, and we can look at the measurement of that. So count the numbers of times each cuisine has been predicted, which looks like this. And we can also do a visualization of that. So cuisine counts and testing cuisine counts. All right. Now we have the data analyzed. Then we can show a visualization to be present to the audience. This is usually done in an automated report and dashboard. So first of all, we want to do the pie chart earlier. And this should give us a pie chart. We have the distribution, gives us the calorie data. And the histograms. Yeah, I'm basically just reusing the code that appeared before and then giving it a better color. And the list plot. And the word cloud. All right. Now everything looked okay. We just need to combine this all together using this function. Yeah, it is a pretty long function, but basically it was just pulling resources here and there and trying to produce the final report. Let me do it slower. So yeah, this is what we're going to present in the end, which has an insight of our data today. So yeah, that is our content of today. The data science pipeline: import, wrangle, explore, analysis, analyze, communicate. So yeah, a data project should just basically follow the idea of the pipeline we're showing here today. And this notebook itself is a rough form of the pipeline, and you can go back and select all and evaluate to see how it works for you. And here we have some further resources that, if you're interested, you can check if your school, your company has the access of Mathematica already. If not, we have this free like 30 days to try, and we have the subscription if you're interested. And if you would like to see more webinars like how it is today, you can go to the WolframU website, and we have classes, we have webinars, we have learning materials here and there. Here are two useful pages for the data science workflow in general. And finally, we have the public resources, more about Wolfram technology in a whole, and the documentation center, and like different data repository, neural network repository that we didn't cover today, but they're pretty useful if you want to try out some examples. So great. Thank you so much for listening today. Our next webinar is next Tuesday, Introduction to Geographics in Wolfram Language. So if you're interested in that, please scan the QR code and register to go to that. All right. Please let me know if there are any questions. And yeah, that will be all for us today. Thank you so much for attending.